Okay, so guys, last time we did these vertical shifts, so I'm not going to spend a whole lot of time here. So, Oscar, if I do 1 plus cosine, we'd just graph plain old cosine, and then what would we do with it?
Shift it over 1?
I said Oscar, Eleanor.
I'm not talking. I'm sorry. Okay.
You didn't give him a chance to talk. You were like, right from the beginning. Okay, Oscar, you get the next one. We do sine of theta minus 2. We're going to graph plain old sine, and then what do? Down 2. Just shift all the points down 2. We did that last time. I'm going to call that good enough for this, okay?
All we do is draw the arrows?
For now, sure. You can graph it. Now, guys, what about on this next one?
Oh, no.
We're adding or subtracting on the inside. How is that going to affect our parent function?
It's going to move it.
Which way?
Left or right?
We're going to go left or right, depending on the sign. So here it says subtract pi fourths. Which direction does that mean we're going to shift it?
Right? Right.
Right. Now, people sometimes get confused when they're like, how much is pi fourths? Well, come down and look at our scale right here. Here's pi halves, so half of pi halves is pi fourths, right? So that means when we go to the right by pi fourths, that's going to be 1 unit. At least on this graph, it's 1 unit. So what we're going to do is we're going to start by graphing cosine. And then after we've graphed cosine, we're just going to shift everything 1 unit to the right, and that will take care of this phase shift.
So starting on 1, we start on 1.
Doesn't this mean it doesn't end the same way it usually does?
Yes, well, so this is, the phase shifts are a little confusing. That's why I start with the parent function for this, okay? So I'm going to start at 1, because cosine starts at 1, and I'm going to end at 1, 2 pi later. Because we don't have any changes to the amplitude, we don't have any changes to the period. We're just going to shift it over when we're done. So here's cosine, there's my start, stop, and my x-intercepts. And I'm just going to draw cosine. Does that look like plain old cosine that we've done several times already? Yes. But now that I've graphed cosine, what are we going to do with each of those points?
Shift them over
1 to the right. Because 1 unit is pi fourths, so then I'm just going to move all of these key points 1 to the right.
So instead of ending on 2 pi, we're ending on... Is the one after? I don't know.
Yep, I don't
These are like, if you're doing the weird heartbeat things in anime, they're almost in sync. You know?
I don't know, but sure, if you say so.
Come on! When they're like together in sync, they have their heart rates on the monitors and they'll match up. And eventually they'll get like together.
Sorry, I don't know a whole lot of anime, so...
Well, I only watch Pokemon, so like maybe saw another anime, I just assume. No.
Alright, let's go to the next one, okay? So this next one is going to also be cosine, but it's plus 3 pi fourths.
Only
So what does that mean it's going to do?
It's gonna move to the left.
To the left, and how many units is 3 pi fourths?
Like 4, like 1, 2, 3, 4, 5 units.
Okay, so let's look at our, no. Let's look right here. So if this is 1 pi fourth, 1 fourth, 2 fourth,
6
3 fourths.
units.
So it's only 3 units.
How is it only 3?
Well, if 1 pi fourth is 1,
Oh, I'm looking
And
at
what's
3 pi
3
squared.
pi
Oh,
fourths?
I see,
It's
I see.
3 units.
It's half of it. I was looking at 3 pi squared.
Okay.
3 pi half.
So, again, we're going to start by graphing just plain old cosine. Cosine starts at 1, ends at 2 pi, so then here's our other points, okay? So this is plain old cosine of theta. I'll give you a second to catch up.
This one, how can you like move it? First point's going off the graph already.
Yeah, we're going to have to start a little bit more to the right. But what are we going to do with all of these key points now, guys?
Connect them.
We're moving them how much?
3
3 in which direction?
to the left.
Are you guys all okay with that? Since we're adding 3 pi fourths, we're going to the left 3 units. Now, I'm going to start with this one and go 1, 2, 3.
Is it like landing on the third, or is it 3 is between them?
It's not landing on the third, it's just 3 units. Because the third is actually, it's not a whole, it's not going to land on one of the lines it's in between. Thirds are tricky. I try to avoid those. Now, sometimes people are like, well, I moved it off, and so now I'm short kind of points. But you can see the pattern here, right? It goes every 2, right? So I was on the x-intercept over 2 and then down 1, and then over 2 and then over 2. So I'll just keep going and follow the pattern over 2, and then over 2, like that. Now I'm going to play connect the dots. And
Wait, why am I so confused?
I'm short points.
that's why I'm saying just follow the pattern, where it's having key points every 2 units. So then just follow that pattern. And there we go. That's how we move it 3 to the left.
Wait. This one also looks like anime heartbeat, but slightly less in sync than the other one.
See, when I see this one, I think of DNA, exactly.
Don't tell me what I know, Travis.
But this one's a wonky DNA. It's not like perfect DNA.
All right. Yeah, it's not perfect. It should have a couple more strands, but whatever. Does the idea of shifting it left or right make sense? Okay, guys, you're almost there, so stay with me. Stay with me. We're just going to do a couple more where we're combining. So we're going to take all of them, put them together.
Nope.
Now, the rule of thumb with this is we're going to save the shifts for the end. So when we're moving up, down, left, right, don't do those. Let's start by doing the period and the amplitude, and then do the shifts afterwards. So I'm going to actually write that down, and if you want to write it down, great. So I'm going to first do period and amplitude.
I have to draw 2 graphs. I guess I can just draw the points.
And then we're going to do the shifts afterwards. So if we're looking at number 5, I want you to turn to your neighbor and take 20 seconds. And there's 3 transformations going on there. And I want you to turn to your neighbor and discuss what those 3 transformations are. Go, 20 seconds.
It's amplitude.
All right, Louise, tell me one of those. Louise/Isaac.
+1, you move the points to the left one.
No, if it was in parentheses.
Or it's up.
There we go, up 1. Awesome.
Up one.
Okay, Emma/Emily, tell me another one. Awesome. And then let's have David/Nelly. Tell me what does that 2 here do? The phase shift will be more over here for adding or subtracting. If we're multiplying, that's going to be the period.
Which is 2.
So we're going to do 2 pi over b. And this number is that. So David, if I do 2 pi over 2, what is that going to turn into? Just pi. So our period is pi, our amplitude is 2, amplitude is 1/2, and then we're shifting it up 1. Okay, now here's a question. We're not going to do all 3 at once. What are the ones we're going to do first? Amplitude and period. We can do those together. So what I'm saying here, guys, is I'm going to start by doing 1/2 sine of 2 theta. Because I can graph that. Once I've graphed that, then what do I just need to do with the key points? Bueller. Do you guys know that reference?
Yeah.
Okay. So what's going on here? There's 3 transformations. Amplitude 1/2, period is pi, and then I shift it up. If I just take care of the period and amplitude right here, when I'm done, what haven't I done?
Have not shifted it.
Shift it up 1. So let's do this and then just shift it up 1, right? That should make our life easy. Instead of trying to do it all at once, let's just do this. So we're doing 1/2 sine of 2 theta. Guys, where does sine start? 0. This is going to go up to 1/2, down to negative 1/2. But when does it end? How long does it take it to go through a cycle?
Pi.
Just pi. So I'm going to do a start point at 0, and at pi it's back to 0. It's only going up to 1/2. It's going down to negative 1/2. That's one cycle of sine. Now I'm going to keep going with that. It's going to go up to 1/2, 0. Down to negative 1/2, 0. I was able to fit 2 cycles in by the time it took me to do, normally takes me to do 1. Now that is 1/2 sine of 2 theta. It's missing the plus 1. So what do I need to do to just make it plus 1? All these key points, I go up 1. And make sure if it was like a fraction before, if it's in between, it should still be in between. So it looks like that. That's your final answer. Does that make sense how you can kind of split it up so you're not doing them all at once?
Yes. But I intend to do all at once anyway.
Don't. You'll probably mess up. No offense, it just happened.
I did mess up like 3 times, but I fixed it in the end. It got
Okay.
it right.
I'm seeing some confused looks. Please ask a question. Where am I losing you on here? Do you have a question, or do I need to re-explain something? We just started at 0 since it's sine. Amplitude was 1/2, so it only went up 1/2, down 1/2. Period, 2 pi over 2 is pi, so it finished in 1 pi instead of 2 pi. It's going through twice as fast, and we just shifted it up. Okay, let's repeat that. Again, we're going to have 3 transformations on 6. I want you to turn to your neighbor in 20 seconds. What are those 3 transformations? This is our last one.
This one.
You're doing? No. 20 seconds, go. All right, Jade Ruby, give me one. One transformation.
It goes, so it shifts to the left.
Left pi fourths. Is that what you're saying? Yeah, good job. Which pi fourths is just 1 unit. So we're going to shift everything to the left by 1. Awesome. Mindy, Melissa, give me another one.
Goes up 1.
Good. Does it matter that that plus 1 is at the very start instead at the very end? Nope, you're still just adding the 1. So if you add 1, it goes up 1. Awesome. Guys, what about the 1/2? What is that? That's your amplitude. So this is actually very similar to what we had last time, where we have an amplitude of 1/2 and a shift up 1. But notice here we're not changing the period because we're not timesing theta by anything. Instead, we're just going to shift it to the left. So what that means is if we're going to start by doing changes to the period and amplitude, there's not a change to the period, just to the amplitude. So we're going to do the amplitude, and then afterwards we'll shift it up 1 and to the left 1. Okay? So
So the amplitude is 1/2. Do we have to multiply? Oh no, I'm thinking it's
so what I'm going to start with,
It's a period. That's what
I'm just going to start with 1/2 cosine of theta. Just change the amplitude. Once that's done, then I'm going to shift everything up 1, left 1, and then that covers it. We're done. So cosine, where does it start?
1.
1, except
1/2.
now it's going to be 1/2. Good job. The period did not change, so it's going to go to 2 pi. So that means at the halfway spot at pi, it's going to be at negative pi, negative 1/2. and I'm just going to kind of draw it like that. So here are my key points. And you don't even have to connect it if you don't want. You just need the key points. So that's 1/2 cosine of theta.
Connect it anyway.
Move this down here like
Now you move it. Move it up.
Okay, so now, since we've got that, we need to make the changes. What are the 2 shifts we're going to do?
Move it.
Move it.
Be more specific than move it.
Move it up and left.
Up 1, left 1. So each of these points goes up 1, left 1. Up. And be careful.
It's half. It's in the wrong spot.
If it's half, you got to keep it in half. So that's up 1, left 1. Up 1, left 1.
That's not half.
Wait, why are we going left?
Because your phase shift is pi fourths. So you need to go left pi fourths, which pi fourths is 1 unit.
Oh, I moved pi four. Oh no, I didn't move. I was. So, confusion. Okay, I get it. Sorry.
Yeah, pi fourths. Garage. That one's middle, isn't it? No, you did zeros. I didn't do zeros. Squeeze zeros.
Okay, so now when I graph this, and yeah, when it is fractions, it's a little tricky because you got to be between lines. But this is going to be 1 plus 1/2 cosine, and then we've got theta plus pi fourths. Sometimes my 4s look like 9s, so let's make that. There we go. Alright, and with that, that wraps up graphing sine and cosine. So now you're going to start your assignment.